Everyone, you're welcome to my channel, and in today's discussion we will be having a video tutorial on linked list. And now linked list is one of the commonly interviewed question. It's one of the question being asked in most interviews, where most interviewer will want to know your basic understanding on Java, JavaScript or Python or any programming stack you're currently working on, because it's a way of testing some of your basic understanding on how you understand your stack and queues, how you understand how things happen under the hood. All right, and now before I go into linked list, I want to basically talk about how data gets saved on your system memory. And now the thing is, in most of the high programming languages, we're talking about JavaScript, we have Java, we have Python, and all of that. You don't have direct access to the memory address of any variable you declare. All right, and that is how it works in most of the high level programming languages. Now the memory management and address manipulation and all of that are usually abstracted away, for you the developers safety and for some profitable reasons, I believe. So the memory addresses of a variable is not typically something you need to work with directly now. But when you go to some low-level programming languages, when you're working with low-level programming languages like C or C++, you know, you have some kind of operators you can use, to obtain, the address of a variable, just assume like I have here on my board. This is how your memory addresses on your system. So now with the low programming languages, you have access to that, the address where you have your variable being saved, and you can have access to see the address where this is. Now, I'm trying to take a little step to explain more of this so you can appreciate linked list, how to create one, and how it works. And now, one thing I want to show you is that most time when you declare a variable, assuming this to be address, the address are in some kind of hexadecimal code. If you have, let's say this address is address x101, and yeah, the next should be x102, and it keeps counting like that. So if you have a variable here, let me, when you declare a variable, coming to JavaScript now, let me use that as an example, or any of the stack you have out there. Now, if you declare a variable, maybe a string or an integer, and there is no, let's assume that gets saved within this address here of x101. Now, when you declare another variable, let's say maybe this time around the first one is an integer and the other one maybe an integer or a boolean or a string of any variable types you have, any primitive variable types, or even the reference. Now there is no certainty that that next variable you declare will get saved in the next address, which is x102, if that is how your address is being arranged or written. So now the first item can be saved here, which is not always the case. Now the next address of the next variable you declare might be stored somewhere in the middle, maybe here, maybe x985, or it can even come here. And when you declare the next one, that can also get, it just gets randomly, save or place on your memory space at random in some random memory address. Okay, and that is how it happens. Now it depends on the size of the variable you want to save, the integer, the size of integer, size of boolean, size of byte, and all of that. So the space gets kind of randomly searched and looked for, and if there's any empty available memory space that can contain that variable, then that will get saved in there. Now let me quickly try to put that on my board. Now I just want us to assume this. Okay, now I just want to assume this piece of boxes I'm having right here will hold, this is the whole memory capacity I have on my device. Now if I store, I have some variables here. I have let x equal 20, and I have let Ismail. I want to have a boolean variable this time around. Ismail equal, this is a boolean of true, and let's name equal Sir Obed. Okay, so now these are some couple of data I have I want to declare, and I want to save this on my memory space. I can have now the 20 can just get placed here, 20, and I have that space. And remember, integer can carry, and I want to assume this is all of this space here should be maybe in bytes. All right, and now if you have an integer in JavaScript or Java or any of the programming languages out there, integer can carry depending on what system version you're using, but it's 4 bytes for 32 bits, all right, on your modem desktop. So now I want to assume the system this is currently working on is the 32 bit system type. Now if I have an integer of 20 here, all right, so that will cover this address. Let me paint all of that. I have 1, 2, 3, 4. Okay. I need to do a Control Z there. So this is taking for my integer. This is taking, and this is the fourth one right through. This is also taking. All right. So X is taking the 20. The value 20 is taking the 4 bytes which I have up there. Okay, so now if I want to declare my next variable, which is the boolean right there, so this will take just 2 bytes. Okay, so and let me have it here. So the boolean that's can come up right here. Okay, and let me cover my boolean. This is true, so the boolean will take just 1 byte. And so I have the boolean here, and the next thing is I have the string here. All right, so the string can come in here, and maybe I have my name, we'll save there. All right, so now that is how this memory just gets at randomly gets placed somewhere. Now this name can come in here because it can fit in this block, so the name can come in here and occupy all of those space. So now if you're working with this in JavaScript or any of the high programming languages, in most cases you won't have access for, just like I explained earlier on, to access some of your memory space and the address of this variable. But if you're trying to do that with C, you get to see where this address get placed and all of that. So now if you have an array, array is like a container for you that helps you to group some data together, and in most cases these are related data. So that is what arrays are. And then with an array, the item gets stacked next to each other. All right, and take for instance, this is if you have an array in JavaScript. Let me say age arrays equal, you wrap your array within square bracket. I have 12, 13, 14, and 15. All right, so now if I declare these arrays of integer, All right. Now within the same memory space which I'm having right now, I have arrays of integers of 5 numbers there. And remember, an integer carries 4 bytes on a 32-bit system memory. So now if I have an array here, what will happen is the the JavaScript or C or any of the stack I'm working on will locate any available space at run on my system that can hold this 4 times 5 integers for me. That is a space that will be sought for. Okay, and that is how array work, and they have to be next to each other. Now if the first item gets in here, let's assume this to be a 4 byte, the next will come next to it, and the third, the fourth, and down to the last item. That is how array works. And whereas for the case of linked list, linked list does not necessarily stack the item next to each other like an array. What linked list does is the item can be randomly placed or anywhere on your system. Okay, and what linked list will do is linked list will hold the current value, all right, and then the next block will be the next block will be an address of the next item within the list. Okay, now let me zoom this out a little. Now I want to assume this to be a linked list, not an array now. So now what linked list will do is this. Linked list will hold this value 12, and then the next block by the side of this 12 will be the address to the next item, which is 13 this time around. And 13 will also hold the value 13 and the address to the next item 13 coming after 13, which is 1, and it goes on and on like that. Now the question is, what about the last item, which is 15? 15 don't actually have any item coming next to it. So now 15 being the last item within the list, 15 will hold its value, and then the next address or the value within the next address block will be a null. So that is basically a null pointer. That is how linked list work. And now the thing is, let's assume you don't have a block of memory, right, that can hold an array which must be stacked next to each other of 5 items, and maybe you have some kind of, because item gets randomly placed, and once an item is placed in a particular memory, they don't get and now you need more space. You cannot tell this 20 this time around to move a little bit up because you needed the space next to each other for your arrays. Okay, and this is one of the things linked list can help you to achieve right now. If you don't have all the necessary space lying next to each other, linked list can place this item at random, right? And all it do is to hold the address of the next item. They get to point next to each other, and that is one of the benefits of linked list. But one thing you should know is that linked list will take more space than the regular array which you're working with, because the regular array just hold for this one more especially you need this is 4 times 5, which is 20 bytes of memory space that must be in sequence next to each other. All right, so you need a space that happens that get that. But if you want to go with the linked list, if you want to save this with a linked list, then you will need this is your 20 bytes of space, and then each items will also need an extra space, right, that will hold the address of the next item. And so the benefit is they must not necessarily be stacked next to each other, and you can have it that way, but you get the item placed in there. So that is how that is what linked list will offer you, the user. And so linked list, they are already both data structure and summary of how that are used to store for storing of collection of elements. just as I explained, these are some of the upside and some of the downside. And in the next section of this tutorial series, I will show you how you can create a linked list, how you can, you know, make some kind of functions or an operation with it. It's just like basically some of those function operation you have with your array, you can also do that on linked list. Okay, and I believe this will kind of expose you to some of those methods you work with an array. Maybe you want to pop some item to remove the last item, you want to push to add to the end of the array. If in the JavaScript you want to on shift, that's to add item at the beginning and all of that. So as I'll show you how you can also implement that kind of function on your linked list. And if you're much more comfortable with the linked list, I think that's a good one. And if you're much more comfortable with an array, that is also a very good one. But one thing I want you to know is they all both have their benefits and their downsides, and linked list is not a substitute to an array. Okay, so and which one will give you in terms of big O notation, in terms of speeding. If maybe you want to search for item, you want to remove an item, you want to add an item, which one is much more faster, which one is much more efficient, and we can also get to see that. But before we end this, I want to show you how you can basically see the address of your item if you have that saved on your memory. Now for that, I'll just create a basic C file and I will call it address.c. So this is a C file, not a JavaScript file. Remember I said you kind of do not have access to see that if you're working with maybe JavaScript or any of the high programming language out there, just for some security reason or thereabout. So now I have a C file, and if you want to run any C file on your system, on Mac, Windows, Linux, or anyone on VS Code, you just need to install the drive that will enable you to run your C code, and that is the GCC. All right. So now if you check on my Mac, if I run GCC version, and then you see I currently have that installed. I have version 15.5.0. Now if you don't have GCC, this is just like the compiler that will run your C program on your system. So you need to have that on your system, right? And you can check that on Google. I believe you get a clear guide on how to install GCC on your machine to run and test any code you write in the C programming language. Okay, now basically I need to require this the standard IO library, because I will be running some prints on my console. So I just include stdio.h. all right. This is just basically, I just want to show you how you can see the address of where your memories, where your items, where your variables are on your system. Okay, I just want to show you that they don't get saved, stacked next to each other. They get randomly placed, and that is basically it. This is not me trying to teach you how to write any C program. All right, so I have that included. That is basically the library I will need, the standard library I will need. Now let me just make a basic function here. I have int main. This is not taking in anything, and within my function body, I just want to get let me declare two variable int. Let me call that a, and then I want to this is not what I want. I want to give it a variable of 102, and then I want to have the next variable this time around. Let me call it int b, and this the value for this is 34. Okay, this should be semicolon if you're writing C, not each statement should end with semicolon. Now let me just print the address of this variable. All right, so I need to print f. I want to get the address of A. All right, that is basically what I want. And then let me also double this line. I want to get the address of the value once again B, and I have it there B. Okay, so now that is basically it. If you check on my file right here, this is the C file. Now I need to compile this file, and then get before I can see the result. Okay, so now all I need to do, go to my terminal, and let me increase this a little so you can see how you can compile and run your C code. And now this is the code you need to run if you want to compile your C code. To call on the GCC and then -o. Now -o means output. This is the name of the output file I want to get. All right, I want to just have the name as address, and the next thing that will come after that is the file, the C file I'm trying to compile, right? The C file I'm trying to run. And now if I run this code, that will create this address file for me, because that's the name I gave it. If you give this name XYZ, then you see a file XYZ being created. All right, so the instruction is very simple: GCC-O, and there's now all what this file will actually contain is this bunch of text, and then the address of A and of B. All right, so now if you check here, let me pull up my Explorer, and then you see we currently don't have any file. Now once I run this code, we see this file get created. Okay, so I currently have my file created, and so I avoid this error, let me address my C file once again, and here let me just put in the void keyword there. I want to have just void, and then I have this here. Okay, so that is, I'm putting that, and also let me pass that here. Okay, let me recompile my file once again, gcc-o, and my file is compiled this time around. Now if I want to run the compiled version of the file here and see what I have, all I need to do is just run the file directly on my terminal, and this is the output. All right, now one thing I wanted to take a look at closely here is the address of both item. Okay, so here I have the address of A and then the address of B. Okay, I'm trying to get this as a decimal. Let me change that. Let me get this like this, but that is basically what I want you to see though. And you can see right here, this is the address of A, and then this is the address of B. You can see they are not placed next to each other. And now even if I have a third variable here, maybe of X this time around, and this can, you see a random, a separate address get printed. Let me compile this file once again. I have my compile code, and if I run that, no, not this, and you see this is my address. I recompile the file once again to that gets kind of like me declaring and running my file, and that is why the address is changed. Right now, if I don't recompile this, the address to this will forever, you can see every time I run that, you see the memory just keep changing, right? But most importantly, you see they are not coming stacked next to each other, and that is how your memory gets placed on your system memory. Okay, so sometimes they can come next to each other, but it is not always the case. All right, and so that is basically it. And now in the next section of this series, we'll create a linked list with JavaScript, and how we can create a node, how we can link them together, how we can perform some various operations. You have to add item to the list, to remove at any location, to put an item in the middle, and all of that. So I will see you in the next tutorial. Please do feel free to subscribe, like the video, share, and if you have any comments, you can put that on the comment section below. Bye, and I will see you in the next tutorial series.